Okay, we're in section 13 of the notes where we're rotating the conic sections. I know it's difficult. We're not asking to memorize a lot of things. We're asking to try to follow the process. Hopefully you understood what we're presenting in class and that you're willing to move forward in the homework. And by doing that, I mean that you're doing a supplemental material, including maybe reading about this. And then once you complete that, do the web assign. All right, so I'm going to go to the homework. And again, I'll go to the whiteboard to do that. The note should be in front of you at all times, though. And just give you 1 second at a clean whiteboard for you. And I'm going to do another share. And again, my emphasis is on that you should know what section we're in of the notes. We're in section 13. I'll write this down for you. And it's the stuff on rotating a conic section. So rotating conic sections. And we're doing the homework. Put number 1 down for you. And again, reading through this, I hope you understand what you've read. I want to point out that sometimes these words, you may misunderstand them. I'm misunderstanding words sometimes too. I should say sometimes a lot. But it says sketch the graph of the degenerate conic. And what does it mean? A degenerate conic is a conic. It may look like a conic section, but it's lost the characteristics. So I'm going to say, just look at this thing, and make a stab at it. I would say this definitely, clearly to me, looks like it's going to be hyperbola. All right, so I want to try to write it in that form over there. We'll try to graph it out. So, x squared plus 2x minus y squared is equal to minus 1. Okay, complete the square. Half of 2 is 1. Square 1, you get 1. I'm going to add 1 to both sides. And, y squared is already perfect. What do you get? X minus, not minus, but plus 1 squared minus y squared is equal to 0. But right now, I definitely know that this is not going to be hyperbola. It's a degenerate hyperbola. So they want me to graph it out, right? See what it looks like. And the way to do that, or at least the way I would do it, is I'm kind of, I don't want to take points and just be here endlessly doing that. But I'm going to write down x plus 1 squared equals y squared. So I'm in a situation now I could actually write down y equals plus or minus x plus 1. All right, so I got 2 lines to graph now. One line is y equals x plus 1, and the other one is y equals minus x minus 1. Let's graph it out because I did ask me to do that. And what would you get over there? X plus 1 is a line with slope of 1 that goes a y-intercept of 1. I'll put that down for you. So let's see, like this over here, right? And then, minus x minus 1, that's a line of slope. Let's see. It'll look like this over here, right? Okay. I want to go to software. I'm going to put my whiteboard down for a second. And I want to emphasize that I want to go to software. I'm going to do another share with you. And I'm going to go to Grapher. All right, give me 1 second. And I'm going to just type it in. Let me get rid of this stuff over here, though. It's from an older problem. And I'm going to type it in. So we get x squared minus y squared plus 2x plus 1 equals 0. All right. I want to point out you might look at this and say, it's really weird looking. I'm going to kind of zoom in to this region over here. And notice over here looks something really strange. I want to do something with the resolution of the curve. I want to try to make it a little bit better for you. And so I'm going to, get the inspector out and, oops, sorry about 1 second, the inspector out. And I want to improve the resolution of this plotting, right? So you notice I have abscissa, this is resolution over here. I was going to try to get it to look a little bit better. All right, it looks better to me now. Now remember what I said I thought these things look like? All right, they look like two straight lines to me. And I want to point out the lines I thought it looked like. I'll write this down for you. X plus 1, that was one of them. Whoops. Just want to turn that off and on for you. I think you see what that is, right? Let me do the other one. And what's everything on y equals minus x plus 1. All right, let's just turn that off and on. I think a clear indication. So what was my computer able to do? Graph that degenerate conic section, right? Very easily, by the way. The resolution had to be improved, by the way. And also graph out the two lines that I said it was, right? It's actually two straight lines, all it is, all right? So I'm going to go back to the whiteboard and I'll do number 2. Number 2 looks like it might be a little difficult. Okay, we just finished number 1. And yes, I did use software just to emphasize that my software could do it too. Gonna do number 2 now. And I'll read it to you. So it's given this equation. Again, you should have the notes in front of you. You should look at that equation. This equation is of the form, they give us the proper form. It says identify the coefficients. So this is pretty easy. So I'm going to put down 2a, identify the kind of coefficients over there. They want to identify the A, the B, the C, the D, the E, and the F. It looks pretty easy for me to do that. I'll write this down. They want the A, they want the B, they want the C, they want the D, they want the E, and they want the F. Identify them all. So what's the A going to be? Clearly, it's 3. What's the B? Well, the B is a coefficient of the xy term, so it's minus 2 root 3. What's C? It's coefficient of y squared, which is 1. We'll check these with the keys later. What's D? D is a coefficient of x, which is 2. What's E? E is a coefficient of y, which is 2 root 3. What's F? It's the constant. It's 0. I'm get my red pen out. See how we did. I see this. 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 Let's go to B. And I'll read it to you. It says, the quantity B squared minus 4AC is called a discriminant. Let me write that down for you. That's familiar, isn't it? It's something you learned from Math 100. What's B squared? Well, it's going to be 4 times 3, which is 12. Minus 4 times A times C, which is going to be 12. That's 0. So the discriminant problem is 0. It says compute the discriminant for this problem. I just did that, and I'm claiming it's 0. Let's see if I got that. Look at my key, and I got it. Let's go to C. See what it says. What does C say? It says, in general, if the discriminant is 0, the graph is a parabola. Negative, the graph is an ellipse, blah, 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 blah. What's this thing? Well, it got 0, so it's a parabola. All right, D. D says this, solve this equation. Well, let's remind ourselves, what's the A? It's 3. Minus what's the C is 1. What goes on bottom? The B. Let's remind myself, what's the B? Minus 2 root 3. All right, I got to solve this. Let me simplify the right side first, which would be 2 over minus 2 root 3. This simplifies to minus 1 right, over root 3. And write this over here. Cotangent 2 theta is minus 1 over root 3. Now, if someone can say, how are you going to solve that? There's many ways to solve it. I'm not saying you can't do something different I'm going to do, but I'm going to write down tangent instead. Tangent of 2 theta is going to be minus root 3. All right, so I want to just remind you, this is a long time ago, I know that, but I'm going to draw my parent curve. And I'm going to say, where would I get the minus root 3? It will be over here now, right? This is minus root 3 over here. And the question is, what's the angle that would do that for me? Well, I'm looking at it. And again, I'm just doing a real simple picture over here. That angle that would do that would have to be, let's see, it would have to give me a ratio of the root 3. I know it's a negative number, by the way. That'd be 60 degrees, right? So I'm going to say this angle over here is minus 60 degrees. Now, whatever that angle is. All right, I'm going to write this down. So 2 theta would be minus 60 degrees plus, just to remind you, this thing repeats itself every 180 degree times, where k is some integer. All right, let's divide through by 2 minus 30 degrees plus 90 degree k. All right, don't be confused. So I'm going to claim over here, looking at it, I'm going to write this over here in radian measure. So it's going to be minus, let's see, that would be minus pi over 6, right? At 30 degrees, 180, yeah, pi over 6, plus pi over 2, k. I think you also remember in the past that we didn't like to write negative numbers down for angles. So I'm going to kind of move up 1. So I'm going to do that for you here. And I haven't looked at the key yet, by the way. So that would be, let's see, if I move up like 90 degrees, that would be 60 degrees, right? Plus 90 degree k. I'm going to write that down in radian. That would be pi over 3 plus pi over 2 k. All right. Let me look at my key. I want to point out, looking at the key, I want to just look at it and see if I've done part of it, solve. I've done that. Now they say the problem. They want the theta be between 0 and pi over 2. So what number would that be? Well, looking at it, it's got to be pi over 3. Okay. What's pi over 3? It's also 60 degrees. Okay. Let's look at our answer. I'm looking at it and I'm seeing it. I'm seeing the solution to the problem that they've written down. Which one did they write down? They wrote down, let's see what they wrote down. They wrote this one over here. I'm just looking at it. And then they wrote this over here. I'm seeing that as well. All right, let's keep going. It says use computer software to graph it out. All right, let's see if we can do that. I'm going to do a different share with you. And what I'm going to do is I'm going to try to graph out that, that equation using software. I'm going to use Grapher again. Again, you're free to use whatever application you want. So I'm going to use computer software. Let me get rid of these things over here. Now let me just delete them. I can always add things later, right? And let me put this down. So 3x squared. I'm expecting this thing to be a parabola that's been rotated 60 degrees. As you're using software, you're going to make mistakes. You should rectify those mistakes. And as part of it, as you have some knowledge of what this thing's going to look like. Sorry about that. I'm really crazy. That's y squared. And then I forgot to do something. Plus 2x plus 2 square root of 3. Yeah, these numbers are chosen carefully to be easy to deal with. Let's see if I've got that. Yeah, I did it. You know what I want to put in too is, I want to look at their graph. All right, so I see my graph. I'm going to zoom out a little bit. I'm definitely seeing a parabola that's been rotated. I'm definitely seeing a rotated parabola. Let me just move this up a little better. That's not so bad, right? Rotated parabola. It's been rotated. Well, let me go back to the notes, see if I've done that. And I'm seeing that. And I think, let me just take a look at my picture again. I think I might have typed it in wrong because I'm looking at it and I'm not seeing the same picture actually. I get 3x squared. Let me put down 2 square root of 3. I'm putting in multiplication symbols, by the way. I'm just reading, make sure I typed in the same thing. 2 times square root of 3y. Let me see if I did it. 3x squared minus 2 square root of 3 xy plus y squared plus 2x plus 2 square root of 3y. Let me go back to my graph. I'm going to look at it more carefully. Again, just looking at the rotated parabola. That's all I'm looking at. And I want to just pull this over here. I guess your scale might be a little differently. I'm going to play around with the scale. I'm going to see what this guy's graph looks like, right? Where the grid. You'll get to learn how to use software. Abscissa. I'm going to say looking at this guy's graph over here, it looks like it's between, I don't know, -7 and 3, let's say. And that's going to be abscissa. That's not good. -7, right? And let me keep going and look at the y-axis. I'm going to say, between y is, let's see, -4. I'm going to say -4.5 and 2. Okay. I'm going to kind of go back over here and look at it again. And I'm certainly getting a better picture now, the picture that they got over there. Okay, I see that. All right. By the way, you might say, well, there's other things. There is a line drawn there. It's got a dash in it. There's another curve drawn over there as well. We'll talk about those later. Okay. But right now, so use photo software to graph this thing out. And I want to point out they want me to graph something else out as well. And looking at it, I'm going to read the title to you. It says, I did the graph of this. I also did this line over here. So I wonder what that is. And that's going to be a line that has that angle of 60 degrees in it. I'm going to type it a little bit differently, though. I want to make sure you understand what I'm doing. I'm looking at the label now. I'm looking at their graph, right? So let me put this over here. And I'll put another curve in. I'm going to put y. Whoops, I already got that. And it's going to be tangent of 60 degrees. I can't use 60. I got to use the radian measure there, right? That's going to be pi over 3, right? I'm sorry. I forgot to put the x in. All right, I see that now. I'm going to make that a dashed line later. And I'm also going to graph in y squared equals minus x. Oops. And again, just looking at the labels, all I'm doing. Okay, I'm seeing their picture now. All right, I'm seeing it. I'm seeing that line. What's that line we're talking about? Hope you remember the pi over 3 business that we talked about before. Let's go back to the notes. And we talked about pi over 3 over here, right? Remember the tangent? I hope you remember that. I like this picture better. A little more detail over here. A nice little dashed line in, blue curve, and then I rotate it. What did I do? I took this blue curve, and it's been rotated 60 degrees. All right. That's all I've done. 60-degree rotation. All right. So let's take a look. And I'm going to go to the next thing up there. The next thing says I want to go back to the whiteboard, and I want to see where they got that y squared equals minus x business here. I'm going back to the whiteboard. Just give me 1 second to get there. I know it's a lot of switching. Let me get dizzy with all the switching. Okay. So I'm on, I did my graph. I looked at it, read the thing, and I'm pretty comfortable with that. So let's go to F now. And they say they want me to transform the curve. I'll write this over here. And it's going to be 3x squared minus 2 root 3 xy. This is going to be a lot of work, this one. Plus y squared plus 2x plus 2 root 3 y equals 0. And what they tell me, they say use those formulas that we derived in class, right? So x equals x prime cosine 60 degrees minus y prime sine 60 degrees. We'll do that. And before I do that, I want to write the other one they would do. They want to say y equals x prime sine 60 degrees plus y prime cosine 60 degrees. These are the same formulas we used in class. I need to rewrite these guys though. X equals x prime, well the cosine is 60, is going to be a half. And the sine of 60 is going to be root 3 over 2, right? All right, let's put down y. That's going to be x prime root 3 over 2 plus y prime over 2. Well, I got some work to do here. And I hate to say this, but I want to do the work. And let me put this over here as common denominator, 2. This would be x prime minus root 3 y prime. This would be root 3 x prime plus, I'm sorry, I put y squared, it's y prime. Let me get my eraser out. This is going to get erased. So y prime. All right, a lot of things I have to do here. And so what are the things you have to do? I have to do a lot of work, all right? And certainly I have to go backwards and do more and more work. But I got to get x squared. All right, that was pretty easy to the bottom, right? What do you get there? You would get x prime squared plus 3y prime squared minus 2 root 3 x prime y prime. Yeah, it looks nightmarish, doesn't it? I got to do y squared. What do you get there? 4. I would get 3x prime squared plus y prime squared plus 2 root 3 x prime y prime. Well, that's done. What else do I need to do? I need to do x times y. Well, that looks pretty easy. 4 there. Then you'd get root 3 x prime squared. I'm just doing one step at a time. And then you would get, I'm going to write this in stages, right? So x prime, y prime. And then you would get minus 3x prime, y prime. I think I should combine those two terms together, right? What would that give me? Minus 2x prime, y prime. My eraser out. And then what do you get? You get minus root 3 y prime squared. All right, here comes another trouble I got to do. I have to do 3 times x squared. Right, I'll write this down again for you. I have to do 2 root 3 times xy. I have to write down y squared. I have to write down 2x. I have to write down 2 root 3 y equals 0. See what happens. All right, see if we can do that. So let's write this down. I'm going to do 3x squared first. So it's going to be 3x prime squared plus 9y prime squared minus 6 root 3 x prime y prime over 4. I did this. Now I want to put this down. Plus y squared. Well, I already have that written down. So it's going to be plus 3x prime squared plus y prime squared plus 2 root 3 x prime y prime. Yeah, it's a lot of work. No doubt about it. All right. I got to keep going. And I'm going to do, let's see what we're going to do now. I guess I would just do this. Let's see if I can do that down. So it's going to be minus 4 here, right? A lot of work. It's really a lot of work. So 2 root 3 now times root 3, which would be 2 times 3, which is 6. Right? Again, what I'm pointing out over here is we're doing this here. And this is what xy is here. And I know it's a subtraction problem. So it's 2 root 3 times root 3, which would be 2 times 3, which is 6. Okay, 2 root 3 times minus 2 is going to be minus 4 root 3. Boy, it's a lot of work, isn't it? Let's see, minus, well, that's going to be 6 again, y prime squared. I got more work to do. A little line over here indicating that this is where all the work is happening. All right. So I got to write down this now. And I'm going to do that from memory. Plus 2x. Well, that's going to be, if I did 2x, it would be x prime minus y prime root 3. Now I'm going to do this. Boy, it's going to be a lot of work, right? 2 root 3 times y. Again, I'm coming from memory, but even what the memory is of my past. We talked about what the x and y were. All right, but I'm running out of room, so that's why I'm talking about the past here. So it's going to be 2 root 3. Put on what I'm doing over here times y. So the 2's cancel. So I would get plus 3. Whoops. Plus 3 x prime. Let's do the next one. Plus root 3 y prime. Yeah, I think I did okay. This would equal 0. All right, here comes where a lot of work is going to have to happen over here. Let me put this over here a little tiny bit. I got to do all that work. That's a lot of work. A lot of work. Let's take a look at it. One term at a time. All right, so what do you got? I got 6 x prime squared. That's these guys over here. Let's see, 9, 10 of those things. Whoa, I got this and I got that. That's going to be minus 4 root 3 x prime y prime. All right, I'm going to say this term is all done. Let's go to the next one. And I'm supposed to get a 4 there, right? I'm doing this guy over here now. One at a time. Ready? So minus 6x prime squared plus 4 root 3 x prime y prime plus 6 y prime squared. All right, that's a lot of work, isn't it? Yeah, I think I better do that now. What do I notice about that? These disappear. Boy, that's convenient, isn't it? These disappear. And what do you get over there? 10 and 6 is 16. And 16 divided by 4 is 4y prime squared. I'll write that down for you. All right, let's keep going. Now, what do I notice about this other business over here? And again, I want to point out where we are. We just finished this guy off over here. All this business over here is all gone. We're looking at this now, what remains there. I think I can do it. So what do I see? Plus 4x prime. That's these two guys. They're gone. And what if these disappear? It equals 0. Wow, that worked out really, really nicely. So what do you go over here? I'll write it down for you. We would get y prime. I'm dividing both sides by 4, by the way, squared plus x prime equals 0. And I'm going to write it a little bit different. I'm going to write it as x prime equals minus y prime squared. All right. And let's look at our k, see if we got that. All right. I know it's a long road for students. They write a little bit differently. Write it as, I'll write this down for you. They write it as minus x prime equals y prime squared. It's the same problem. It's good. This is good. This is good. All right. So we did that. And I'm going to say, for the most part, I know it's tough. And I realized last year, like, could I ever do that by myself? And we really believe you can do it yourself. It just takes time and effort. All right. Also, a computer algebra system would be nice to use and something like that. All right. Then go to number 3. A little more complicated, but it's a solution to a problem. And looking at it to solve the quadratic equation algebraically. And I'm glad for that because I really don't want to go all that, work about graphing these guys over here. And I'll write the system down for you. Looks terrible. I want to point out there is no such thing as terrible at this level of the game. If it's working out to be terrible, you're probably doing something horribly wrong. I hope I copied right. And before you do anything, I want to point out, I'm noticing things over here. What I'm noticing over here is that I have a hyperbola. That's the top equation. At least I hope it's hyperbola. And the bottom equation, for just looking at it, it looks like it's going to be an ellipse. I don't want to graph it out, but a graph is provided. What I want to do is I want to make some attempt to solve it. All right. So it says it looks really tough to solve. I'm going to say right from the get-go, I am going to try to add these things together and see what happens. And I'm hoping, complexity distribution to do that. But what do I get? 17x squared. The y squares disappeared. Good for that. Minus 170x. The y's disappear. right? And then what do you get over there? Minus 247 and 400, that's going to be 153. Did I do that right? 153. All right. Whew, that lesson doesn't look easy. Let's see if I copied right. And minus 170. And 64, 247, 153. I'm going to try 17. Yeah, let's see what happens. You may wonder why I paused there. I want to make sure that I can do the arithmetic. So 17, it's wishful thinking, maybe minus 10x. I'm going to try to do 17 times what number? Would be 153. Can't be that difficult, right, if it's going to work out. I'm going to say 9. Let me see if that works, though. What's 9 times 17? 90 and 63. Worked out beautifully. I'm going to divide both sides by 17. And I'm going to try to factor it. I'm going to say 9 and 1. I'm going to say minus minus. So x equals 1 and y equals 9. I want to point out this is as a solution to it. The candidate at this point would be x equals 1, y equals 9. And I don't want to do much work over here, but I would like to try to figure out, x corresponds to something. Maybe a y, right? And this would correspond. Well, I'm sorry, I made a mistake there. Just penmanship alone. It's an x. I don't know. Which one do you think might be easier? I think the one's going to be easy. All right. So I'm going to go through that with you. And not that I want to do a lot of work in front of you, but I do want to point out pictures provided to you. Certainly they're good pictures. I did on a computer. I just want to go through one of these computations and leave the other one for you to do. I want to do this one over here. I'm going to do the one. What would I do? Plug it in. First equation. What do you get? 1 minus 4y squared minus 10 minus 64y minus 247 equal 0. Let's keep going. Minus 4y squared minus 64y. That's this one, this one. Let's add these numbers together. Let's see, minus 247 minus 257, and then plus 1 minus 256. I'm going to divide both sides by minus 4. You get the idea, right? And what do you get over there? That would be minus 64, right? Well, I'm going to do this now. And what would you get over there? I guess 64. I'm going to say 8 and 8, right? Wow, that's convenient, isn't it? Oh, I'm sorry. I made a mistake in the this over here. It's plus 64. Sorry about that. I divided by minus 4. So plus 8, plus 8. What's y? Minus 8. Okay, that's nice. By the way, I want to leave this one as an exercise for you. You're going to do the same thing. You're going to plug into one or two equations. By the way, you get another problem over here. You have to verify this works in both equations, just like we did in the past. But I think you can do this. You eventually get another solution over there, and it's going to turn out to be pretty simple too. It's also going to turn out to be minus 8. But you do the work. All right. I want to point out, if you're looking at the rest of the notes, I know it's a tough section, by the way. They want you to do some optional problems over here. No, you don't have to do optional problems. If your objective in life is to take the easy path, please take the easy path. Just do what you're expected to do. The option stuff might be too difficult for you even to consider. But again, if you think about moving forward and be competitive, I would start looking at these optional problems. They could take a long time for you to do, though. You can talk about hours of entertainment if you find it entertaining. I wrote the notes for you. I'm not going to say I find it entertaining, but I kind of do. I like writing that stuff down. I like getting through it. I like struggling with things. And this is for a lot of students would be a lot of struggle, but number 4 is optional. A lot of work there. I put all the work down for you. And then there's related sage code. In your related sage code, it's basically more implicit plots. That's all it is. Same stuff, same stuff, same stuff. All right, good luck to you.